So we're back again with a video on insulin and insulin resistance. And before I touch on insulin, I should talk a bit about inflammation. 2000 years ago, Aurelius Celsus observed that inflammation has 5 signs: calor, warmth; dolor, pain; tumor, swelling; rubor, redness; and functio laesia, or function loss. So whenever you get injured, let's say you have a broken finger or a sprained finger, you will find that it has calor, it gets warm. You will find that it has dolor, it hurts. You will find that it has tumor, it swells up. And you will find that it has rubor. Rubor means the redness before it turns bluish black. And you will find that it has a function loss till you repair the finger. So why do I bring up inflammation when I am talking about insulin? Because insulin is a pro-inflammatory hormone. Pro-inflammatory means that it promotes inflammation. Naturally, we are not talking of external inflammation, but internal inflammation. The problem with internal inflammation is twofold. One, that we cannot see that, and the second is that it is a very low level, but a chronic condition. Why do I talk of inflammation? Because inflammation has been connected to insulin resistance by a number of studies, and insulin resistance in turn is connected to several or many, or I would say most, if not all, metabolic chronic diseases. In fact, aging itself. So now let's come back to insulin, now that you understand inflammation. Insulin, as we have told before, is produced and secreted by the beta cells in the islets of Langerhans in the pancreas. Insulin response takes place as soon as you have consumed some food. But insulin's role is primarily that of distribution and storage. So it doesn't just distribute glucose, which is the more well-known role of insulin. It distributes a lot of other minerals and other stuff as well. So let's look into what are the roles that insulin plays. Starting with glucose metabolism, as soon as you consume food, presumably containing some carbohydrate, glucose is released by the liver, and proportionately the pancreas responds with secretion of insulin. The first thing that insulin does is to tell the liver to stop delivering any more glucose to the bloodstream, rather to keep converting it into glycogen and storing it within. Then it takes it mediates that the muscle cell take up the circulating glucose, so that can be converted to energy, and some can be stored for later use as well. Stored muscle glucose for energy doesn't come back into the system. That's something to keep in mind. Thirdly, after it has shut off the liver, after the muscles have had enough, if there is any more surplus glucose still remaining in the bloodstream, insulin then suggests to the fat cells, the adipose cells, that you take up this glucose, convert it into fatty acids, join them, 3 of them together with glycerol as a triglyceride, and store them as fat for use later during days of starvation, famine, and all those things. Now, what is insulin resistance? So, over a period of time, usually running into at least a decade, cells of the system, the body, due to the over use of insulin and the over presence of insulin become resistant to insulin. They just don't want it anymore and they say, okay, we've had enough, please go away. When the cells become insulin resistant, naturally all these roles that we've discussed a little bit and some that we are going to discuss become curtailed or completely even shut off. So I'll show you how the insulin resistance has a cascading effect. Let's take the case of insulin's dialogue with the liver. So as I mentioned, the first thing it does is tells the liver, stop sending any more glucose into the bloodstream, rather convert it into glycogen and store. When insulin is communicating with the liver and the liver cells have now become insulin resistant, they don't listen to what insulin is saying. They continue to keep releasing glucose into the bloodstream. The brain thinks that, oh, more and more the glucose concentration is going up. Probably the pancreas have not released enough insulin. They ask pancreas to release more insulin. Cascading effect. Let's take muscles. When insulin delivers glucose to the muscle for storage and for use as energy, when the muscle cells become insulin resistant, they don't accept the glucose and fatigue and tiredness sets in because muscles require that energy. Secondly, again, since they are not taking up glucose, more and more glucose remains in circulation. Again, the same cascading effect. Brain thinks pancreas is not secreting insulin, so it asks the pancreas to dump more insulin. The fat cells are the last to become insulin resistant. All of this takes place in a very phased and step-by-step manner. First, it is the liver cells which become insulin resistant. Then it is the muscle cells which become insulin resistant. And finally, it is the fat cells which become insulin resistant. So in the presence of so much insulin and so much glucose, ultimately, since muscles are not taking up glucose, since the liver is keeping on dumping glucose, insulin is forced to deliver the glucose to the fat cells to be converted into triglycerides and stored as fat. Naturally, your girth goes up, your size goes up, your weight goes up, you become overweight and obese. And there comes a plateau point where even the fat cells will become insulin resistant. That plateau is different for different people. So somebody may put on 100 kgs, somebody may put on 110, 120, 150 kgs, but at one point of time, even the fat cells become insulin resistant. Now insulin, as we said, is a pro-inflammatory hormone. So more and more insulin present in the bloodstream means a lot of inflammation is taking place. It is an anabolic hormone. Anabolic means that it joins things together. So stuff keeps building up. It encourages growth, which is again within the circulatory system, vascular system. It's a dangerous thing to have. Thirdly, it is a mitogenic hormone, which means that it proliferates cells or it encourages cell division. That again is a problem with so much insulin circulating in the body. Let's look at some of the other important roles of insulin. As I told you that it is a hormone which is primarily responsible for distribution and storage. So insulin distributes a lot of other minerals. For instance, magnesium. It delivers magnesium to the muscles. Why do the muscles need magnesium? Magnesium is required for the muscles to relax. Magnesium has no storage in the body, so if it is not consumed, it's going to be removed in urine. So insulin has a role of delivering magnesium to the muscle cells. In the presence of insulin resistance, with so much insulin floating around and the cells becoming insulin resistant, naturally insulin is unable to deliver the magnesium to the muscles, and as a result not only does fatigue set in, the muscles become weaker. They are not able to relax. They are very taut and tense all the time. The muscles of the arterial walls, when they lack magnesium, they tend to constrict, shorten, or that the diameter or the flow of the blood gets constricted. As a result, your blood pressure goes up. Then insulin also is responsible for distribution of calcium. Again, the same story. If the calcium is not delivered to the bones become weaker and osteoporosis sets in. Insulin also regulates the storage or the retention of sodium. Sodium retention means, along with that, fluids need to be retained. And as a result, when more sodium is retained, more fluid is retained, you tend to swell up. Especially you will find swelling in your feet. And as a result of your fluid retention, again, blood pressure goes up. Insulin is very much responsible in lipid mediation. So it helps in the lipid uptake by the cells also. So more presence of insulin means you're going to have a very, very distorted cholesterol panel. As we've already discussed, it delivers the fat to the fat cells. The fat cells convert it into triglyceride and store. So naturally, insulin has a large role to play in your triglyceride levels, not just triglyceride levels, but your LDL, HDL, all these things are also regulated by insulin. Insulin definitely plays a huge role in the lifespan. There have been a number of studies conducted on centenarians, and a lot of research has gone into trying to find out commonalities or the reasons why centenarians, people who live beyond 100, live beyond 100. And scientists could not figure out. Some of them were smokers, some were not, some drank a lot, some did not, some were good-natured, some were very, very vicious. So they couldn't find out what is there in common in all these centenarians across the globe, except for two things. The centenarians had low insulin and the centenarians had low triglyceride. So insulin is definitely a modulator, a regulator of the variables of longevity, lifespan. Use your insulin well, use it sparingly, use it conservatively, so that you can, if not extend your lifespan, at least you can improve your chances and be in good health for a longer period of time. I hope you've enjoyed this talk, and do share, subscribe and like our channel. Thank you very much.